Hello everyone, my name is Suman. So in the last week we have discussed about different filters and their outputs. So in this week let us see about those filters only with different inputs, like we give the input using a sensor. So in the last week what we have done is we have initialized the input in an array and gave that input, and we have observed the output. So here we read the input to through the sensor and we observe the output. So let us see first about the moving average filter. So what is difference between those both is, so there we have initialized an array with some values. Here we initialize an array and we run a loop, and we use a command known as nlogread, which reads all the values from the sensor and stores those in the array. So here in nlogread in bracket we have written a0, which is a analog port, which is an analog port in the Arduino device. There are 8 analog ports from a0 to a7. So here I have used the a0 port, so I have written a0, and those are stored in a array known as sensor value. And here we use the command delay. This 10 represents 10 milliseconds. We use the delay so that the sampling is happening. The sampling frequency here is 100 hertz, so we are taking the time 10 milliseconds, so that there will be no overlaying or aliasing properties observed. And next, the remaining code is same as the moving average filter. So let us observe the output. So here you can observe, as there are small peaks here, but the output is being smoothed as the moving average filter does. So let us go to the next part, which is the first order differential. So it is the same here. We have used that array sensor value, and we have read the values and stored it in the sensor value array. And as the first order differential, we have sensor value of present input minus the past input. Everything is same. So let us observe the output. See, here you can observe where there is small peaks in the input. It's being emphasized as high slopes are emphasized. As the peak goes down, here the output still goes down as it magnifies the high slope values. And this is the first order differential. Now let's go to the next part. So the next part is design a MA filter with L, which is the length of the filter, equal to floor of 0.8 into n, which is the number of samples or input values to extract baseline drift component from a signal. So here the sample value can be any value, it can be 500, 250, and it is multiplied by 0.8, so it gives a high length which almost smooths the curve, and if the value is some 243 or 242, we can get a decimal value, so we are using the flow function so that we get an integer and there is nothing. So let us see the output of this. So here you can see the same sensor value and everything is same. Here the length we are multiplying 0.8, and as the input is 250, we are multiplying by 250, and we are doing by 1 so that we get the integer value. So the remaining code is same as the MA filter. See, you can observe here as this one goes up and down, the curve is almost smooth. When it goes down, it goes at the bottom, and you can observe that it is a smooth curve with no. So here we get the most average values as we are using the highlight. So let's go to the next part. So in the next part, what we need to do is find the output of signal processing system which performs derivative filter tool, which is the derivative in the first order reference, and then perform MA filter with n equal to 8. So here firstly the signal is passed in the derivative filter, and the output of that is passed into the MA filter. Let us see the code. So here firstly everything is same, values are right, and firstly we have passed into the first order derivative filter, and that output here is passed into the MA filter. So here we can observe three graphs, which is the input, and the first output, which is the output from the first difference, and the final output, which is the MA filter one. So let us see the graphs. See, so here you can observe the blue part is the input part, and the red one is the output from the first order differential filter. Here the slopes are being emphasized, high slopes are being emphasized, and when it is passed into the MA filter, it's being smooth. You can observe it in the green color line. So that's it for this week. Thank you.